All right, let's get started. And last time, in addition to doing the general introduction, I also talked about Lab 1, how to go through Lab 1. Well, I do want to say I made a change to Lab 1. I took out the material on assembly language because it's kind of a logistical problem. Some people are working on Mac, some people are working on Windows, and that assembly language code only runs on Linux. Right? So it just became sort of inconvenient to have everybody go through that exercise. Although I think it was useful, but each quarter I'm always tempted to take that out. So I decided this time to chop that part of the lab. So I distributed the points over the two other sections. So 15 points for getting a hello program to run, and 15 points for learning the Linux command line interface. And so that's my adjustment to Lab 1. But today I want to talk about the material, the concepts, and knowledge that you need to understand and do Lab 2. So Lab 2 is about, I have the word expressions. It's about many things, but maybe the most important idea that I want you to pick up in this part of the course is the idea of an expression. What is an expression, and so on. So I'm just going to return to the folder I was last time. And just so you can see me work a little bit, because this is what you would do in the lab. Although you don't need to work in the lab to do your assignments. You can work on a Macintosh computer. You can work on a Windows computer. You can work in the lab and bring your laptop, or just stay at home and work there, whatever. It doesn't matter. But if you do, well, let me answer your question first before I go on.
There's no Linux really required for this course. We just have to be good in C++ programming. We don't have to.
Yeah, the only Linux required is that Lab 1, just to get a taste for it. But if you take other classes in the School of Computer Science and Engineering, you will be required to do work in the Linux labs. Okay, so it's good to practice that a little bit. I recommend doing some of your exercises in the lab under Linux, and some of your exercises, on Windows if you're using Windows, or Mac if you're using Mac, and so on. Your question?
In the lab after this, are we doing Lab 1 or Lab 2?
Wherever you're at. If you haven't finished Lab 1 and you're confused about something, I want you to ask questions about that part of the lab that you're confused about or that you're stuck on. So finish Lab 1 first, and then move on to Lab 2. But the labs are, let's see, is this our second meeting or our first meeting? Yeah, so this is Lab 1. So this is Lab 1 for people. But for the people that are going to their first lab today, you'll be able to run through the Lab 1 exercises pretty quickly, I believe. Lab is long. Is it 2.5 hours long? Something like that, right? So you have a lot of time. You could actually start Lab 2 today after you finish Lab 1. So the lab today is mainly about Lab 1. And I will be in there, and I'm going to help everybody kind of understand the basis that you need to know. I'll go over these commands in the lab. I will go over these commands. I'll talk about them. You'll want to play with those and understand those. If you're in the lab with your Windows machine, you can sort of look up the equivalents of these, how to do these commands at the command line in Windows or Mac. You bring your Mac with it, whatever. And then there's also the hello program. So you got to start practicing compiling and running and debugging and modifying source code. So that's the goal of Lab 1, is to get to learn about your environment a little bit, the environment that you access through the console window, through the command line. And then the second thing you need to sort of start getting familiar with is this cycle where you develop source code, you compile the source code, you run the source code, you run the resulting program, and then you go back and fix the source code because it didn't work right or it was not yet finished yet, and you just keep going through that rotation. Yeah.
So when we're in our labs later, that's just all we're going to play in, and that's going to give us the holo.cpp?
Yeah, this will work.
Oh,
You know, what you do is basically copy this. You don't, just copy that thing, paste it into a file. Save it, compile it, and run it. That's it. I just did the lab. That's how quickly you can do lab 1. So there's 3 steps. I modify the source code, I compile it, and then I run it.
So modify, compile, and then run.
Yeah, and then go back and repeat because you've got to fix problems and whatnot. Yeah.
It's easy enough to like write the code if you have Node++. I get that. There are online compilers that test if your program can compile it.
You can compile your code online. You can use an online compiler. Paste your code inside a form on a website, have it compile, run, test it, pack it up, send it to Jaren, CC me. That's your lab submission.
Okay, because I've seen I've had it test will it compile? Yes, it compiles, but are there online sources that will actually run your code too?
Yeah, there are.
Oh.
I don't know what they are. They're out there.
Oh, okay.
They're out there. So you can find a website that'll have a form, and you can write your code in the form and then actually compile and run it right there in your web browser. Yeah.
How do you save the program on VI? When you saved it before you exit it?
Say that again?
How did you save the program on VI?
I did right. So in VI, I'm just going to show you VI. For those people who want to learn VI, it's optional. I recommend it, if you're in a computing field, to be somewhat familiar with it. You don't have to be a master of it. So it's the arguments. And VI is the command. It's a text editor. And this is the argument to the command, which is the name of the file to edit. And then you can move around. The mouse doesn't work here, so I can't use the mouse. But I use the cursors to move around inside. And then when I make a change, like that, see, to make a change, I press I here, and I go into insert mode. You can see the word down here, it says insert. I've gone into insert mode. If I hit escape, I exit insert mode. So I insert mode, escape, exit insert mode. So you can toggle there. And when you're in insert mode, then the editing works like, say, Notepad or something like that, WordPad. You can backspace, delete something, and then change it. Now, when I'm done, watch, I'm still in insert mode. I press escape to leave insert mode. And then I want to bring up the command, so the command line, the command interface. So I press colon, so it's shift colon key. So it's a colon. And then I can enter in commands. So W is write. So that saves the file. Do you see out there? See t.cpp written? Was that 101 characters written? 8 lines, 101 characters written. And then I can quit. So I go bring up that command prompt again. I press colon. Now this is called a prompt. A prompt is a place where you enter in commands. And there's a command Q, that quits. So now I quit the VI program. Now I'm at the terminal command line. This is the console command line. It's a different command entry prompt. But I did this, when I make a change, like this, then I can do write and quit all in one shot. So that's how I save and quit at the same time. I'm going to remove t.cpp, that's deleting a file. ls, I just want to check to see it's gone. Yeah, it's gone. I don't need a.out. That's a derived file. I can always regenerate that easily. See, a.out, oh, sorry. It's remove a.out. A.out is removed, but it's a derived file. I just have to generate it again. It's easy. I use the compiler to transform the source code in main.cpp to an executable file, a.out. That's the default
If
name.
you just kept compiling it,
Huh?
if you kept compiling it, would it generate multiple a.outs?
No, it'll copy over the old one.
Oh, okay.
So this is It just writes over the old one. If I use -L, it's a long list. Look at the time, 12:13. A.out was created on 13 minutes after 12 o'clock. All right, so let me run the compiler again, and I'll do another listing. It's still 12:13. Still 12:13. So we got to wait for a minute to go by, right? Ah. $12:14. All right, finally, that's a one long minute. All right, and clear to clear the screen. And I'm going to make a folder, make dir, mkdir. This is also on Windows, same command. I'm going to call it lab1. See that? Now I have a folder called lab1, and my main.cpp. I'm going to move main.cpp into lab1. See the command? This move command takes 2 arguments. And the arguments are source and destination. So the source is main.cpp. It could be a folder, it could be a file, it could be a pattern that matches multiple files, and lots of different ways to specify the source. And then you have the second argument here is the destination. And as you can see, it's lab1 with a slash, so that tells the interface that this is a folder, a directory. And we want to move main.cpp into that folder. I do ls, I see it's gone, but if I do ls lab1, ls with no argument shows me the contents of the current folder, but ls with an argument shows me the contents of the folder specified by that argument.
Is that slash just the end of the argument, or is that actually part of the title?
It's part of the path. See, actually what I'm doing, I'm hitting the tab key, and that does what's called command completion. So the system added the slash to let me see that this is a folder. And I'm listing what's underneath this folder. So if I leave that out, I get the same result. Let's make another folder. Let's call it lab2. There it is. Now cd into lab2. pwd, print working directory. See, this is the path to where I'm currently positioned in the file system. So this is the root top level. Under the root is users. And I'm a user under that users folder, Turner. And then under Turner, this 201, I created that folder in my home directory. This, by the way, this is called your home directory right here. And then under 201 is another folder, lab2, and that's where I'm going to work today. So I'm going to work in lab2 programs. Now, rather than writing everything from scratch, I'll make a copy of what I did in lab1 and then use that as a starting point. So I'm going to use the cp command. I think on Windows is it copy or xcopy? Who uses Windows? How would you do copy? You spell it out C-O-P-Y?
Yeah, xcopy is going to force it.
Huh?
Xcopy is only going to force to copy it. Won't let you do it otherwise. Xcopy is only going to make
So
it.
xcop, say it?
If it's a save file, if the file is like administrative access or something, it's like turns out a file, you need xcopy. Otherwise, for a normal folder file, just copy.
Just copy. So in this case, regular copy is okay. So you know who to go to if you're working on Windows, by the way, in the lab, right? Hold your hand up and say, I can answer those questions. Very good. Very good to be a resource. So I'm going to see the ... That says that's a specifier. It specifies the parent folder. So I'm specifying the parent folder. Then under the parent folder, I want lab1, and under lab1, I want the file main.cpp. So you see the path. That's called a path. It's a relative path. It's relative to where I am. It's relative to the current directory or current folder. You know the word folder or directory, they're the same thing. So I'm going to go up to the parent, then down through lab 1, and then get the file that's in lab 1 called main.cpp. That's the source. So I copy source to destination. Where do I want to put it? I want to put it in the current folder. How do I name the current folder? What's the fastest, easiest way to name the current folder? Dot, good. I think I heard that. See, the dot means current folder. It's like dot means the parent folder. It's the same on Windows. So now I got main.cpp. I'm going to use this thing called screens. I have these virtual screens, so I use that a lot. I'm not going to get into how that works, but if you want to learn that, you can look that up. And so I'll edit this. So here it is. This is the program. It says bye. And I'll just do something. I'll say OK. I'm just setting up my development environment. So I've got the text editor. I've got my editor open. Not that one. And now I've got another window, and I'll use the compiler there to generate a.out. And a run a.out. You see the ./ there in front of a.out? What am I doing here? Why do I have / to run this thing? Why don't I just do a.out? Well, a.out, command not found. Huh?
Tells you which directory.
Yeah, we got to tell it which directory to look in. And dot means the current directory. Look in the current directory. Good, thank you. So let's go. Now we kind of have our development environment set up. We tested it, made sure we can build and compile a hello program. So now we're ready to go. Now we're going to try to tackle some kind of a problem where we want to write code. So let's go to the lab. This is the list of learning objectives. So lots of information here. I'm not just going to go through that. I'd rather just show you things by doing things. Exercise 1. Also, I put a link in here. This is something I've never actually linked to before. This is what's called operator precedence. And this table can be very handy for you. And I'll give you an example. If you print, let's do this. Let's print 2 plus 2. What's that going to print? It'll print 4. Because 2 plus 2 will run, this addition will evaluate first, and then the output operator runs. So we have addition, which is here, sort of like this precedence level 4. Then you have this output operator on the very next level. See that? So the addition, the plus operator, is evaluated first before the output operator is evaluated. So this table shows you what's called the precedence levels of different operators. And these are all the operators in the language. And we'll be looking at a lot of these, maybe half of these operators you'll be responsible to understand, not all of them. Well, we better test this, which we can do very quickly. If we get this, whoops, I'm using the up arrow, that's a command history. So I'm pressing up arrow to go back into my history of commands that I've issued. But if we do this, if I multiply by 3, what do we get? We get 8. That's because multiplication here has a higher precedence than addition. So we do the multiplication first. It's just like what you would expect from what we've learned from in grade school about the order of operations. That's called operator precedence. And there's a link to that table. All right, let's take a look at exercise 1. write a console program. So console program means a program that runs at the command line. So to test this program, you need to be at the command line. And the other kind of programs are normal programs, or window programs. So you see this is a browser here. That's a program that's running. It's not a console program. It's a graphical program. It creates, when the program launches, it tells the operating system that it needs a window that it wants to control. It wants to write to a window. And so I get this window. See, this is from the operating system, and the browser asks for a window. And OS 10 gave this window. And then what did we do? Well, we created tabs here. We created these symbols and this menu and so on. So that's all part of the program. That's called a graphical program. But we're not going to be writing graphical programs. We're going to be writing console programs. Those are programs that we run at the command line, like this. It doesn't have to be called a.out. It could be called something else. If we use -o, we can give it a name. Let's call it, say, main. Now we have a file in there called main that's executable. So we just invoke it that way. So the name of the executable is arbitrary. So we're going to write a console program that prompts the user for 3 double precision floating point values, x, y, and z. So we're going to ask the user, please tell me x, y, and z. What numbers do you want to use for those variables? And the user is going to say, well, I want x to be 1, I want y to be -3.9, and I want z to be 0. So we don't know what the user is going to type in, but whatever they type in, we're going to assign it to those variables. Once we get those values from the user, we're going to calculate the sum of those 3 values. And then we'll display the sum of those values. So there's some steps there. Prompt the user. For x, y, and z. Compute. Oh, sorry. It's actually a little tough to type while you're standing up. I don't normally do that. Compute x plus y plus z and print the result. And then, do other things. So let's add that in there, okay? And then we'll, now these are comments. Do you see the // That tells the compiler that this is just a line for the programmers to read. It's a comment in the source code. It's ignored by the compiler. Should just say okay. This says nothing, right? Oh, sorry. This should be like okay. Now, so we want to prompt the user. So prompt the user, we have to ask the user. So look, I just pasted this in there. So I can do something like this. I'll say, we could do it many different ways. I'll just say x equals, and let the user enter in the value for x. And I already know that I don't need that part because the user is going to hit the enter key, and that'll bring us to the next line. So we don't need to print a new line there. Of course, it doesn't do anything. Actually, now we need to input the value. Okay, so cout is where we're sending something to the output stream, standard output stream. Now let's go the other direction. And let's use the standard input stream, cin. This time we're going to read the value x. We're going to pause and let the user type something at the console, in the console, on the keyboard. We'll let the user type something on the keyboard, and we're going to wait until user hits the enter key or the return key, the value will be converted to a floating point value x and stored in x. Now this is not going to work as it stands. We are going to get a compilation error. Let's see what we get. Compilation error. This is different than a runtime error. Runtime error means the program compiles, we get an executable, and then we can run the executable. But when we run the executable, maybe we get a bug, right? We have a problem. But that's called a runtime error. This is not a runtime error. We did not generate an executable. The compiler is saying, I don't understand what you want me to do. I cannot generate an executable. This compilation error. Was there a question?
In your opinion, what's more frustrating?
The compilation errors are trivial. You'll see. As you get better at this, compilation error is just a trivial little thing. It's like breathing. Take care of those. And but when you're beginning, the syntax errors, compilation errors seem to be a big deal. But later, they're nothing. The problem is the logic errors. You know, you're playing that game and you're 3 hours into the game and then the thing freezes up, right? That's a logic error. It's not a compilation error. That's hard to figure out. Now, the people that wrote that game and released that game, they didn't know that was going to happen to you. And now there's like, well, what happened? I don't know what happened. Then they have to do some research. You've got to look at log files, and it's very complicated to figure out those things. So look at the error message here. Look, this helps you out a little bit. This shows the line number. So it's line number 6. This is the position on that line. Now this line number and column number is it's an attempt to help you find the mistake. It may not actually be where you need to look, okay? So just keep that in mind. It's usually where the problem is, but sometimes the problem comes earlier in the code or even later sometimes. Here's the error. Use of undeclared identifier X. Undeclared. We said read the value into X, and the compiler says, yeah, but what's X? I don't know what you're talking about. And so we have to tell it what X is. And let's do it like this. I'm going to say double X. That does it. That says compiler. I want an identifier called X, a variable called X, to store double precision floating point values. That means, you know, use memory, use 8 bytes of memory. A floating point number. Well, what is a floating point number? What's the difference between a floating point number and a different kind of number? It means it has a decimal point, a 3.5. And the other kind of number would be something like an integer. So you would cut int x. That means x is an integer. Here, x can only contain integer values like -3, 79, but it can't store 6.5. To store 6.5, we need a floating point value. Double is the standard data type for that. You can also use float, but a float gives you 4 bytes of memory. And float is used when you have a lot of data, like in video games, and you've got, you know, models, and you've got terrain, and you have things that you visualize. All those numbers internally are stored as 4-byte floating point values because the precision is good enough. When you log into your bank website and you do a transaction with the bank is operating on 8-byte values. They're not, well, they might be working on integer values actually, but they're not going to store how much money is in your account in a 4-byte floating point number because it's not precise enough. It's possible that you could lose a penny, you know, depending on what you're doing. But for multimedia applications like video games and video data, image data, even large scientific data sets, if they're very big, if 4 bytes is enough space to represent your data, that's what you want to do because you're going to save, you'll save, you know, half of what you would spend if you were using 8 bytes. So let's use double there. Anyway, now like this solves the problem. The compiler said use of undeclared identifier X. Well, now we declared it. Let's see what happens. Well, I had to make a mental note. Oh, this might fail. If I didn't save my changes, this is going to fail. If I save my changes, I think it won't fail. I must have saved my changes. So it's a typical mistake. You change your source code, and you go back and compile and run your program and get the same result. I mean, you didn't know that. You didn't see, you missed that you didn't save your changes. It's something to pay attention to. So now we actually pause and wait for the user to enter a number. That's how you enter a number into the running program, through a console, through console install. Normally, most applications don't run at the console. They run in windows like this, and here you would click the link, so the data wouldn't be a number that the user's inputting. It would be, say, the XY coordinate of the cursor, where it was clicked on the screen. You get that information and have to respond to that. So it's a different kind of user input, but we're just looking at text input from the user. I just want to mention that you won't be able to type in something that's not a number. It looks like it's okay, but it's not going to work. And we could test for the user entering in bad numbers. We could do that, but I'm not going to focus on that. We're going to kind of gloss over that point. We're just going to assume the user enters in a valid number. So now we need to prompt the user for X, Y, and Z, but we're only got X right now. And I want Y and Z as well. Prompt the user for X, Y, and Z, and read it in. There it is. We have to compile to regenerate that. Oh, we didn't get it right. Same problem, by the way. I'm going a little fast. Error, use of undeclared identifier of Y. I forgot to declare that. That's a bug. All right, let's go back. It's not a bug. It's a syntax error, or it's just a compilation error. I don't think you would call that a bug. I would use the word bug to represent a mistake in a program that runs. We can't even run this. All right, we can't generate the executable. So I wouldn't call that a bug. Just a compilation error. Right. Let's do this. So double Y and double Z. Now it seems to work. X, Y, and Z. There we go. So that's how we get the numbers in. Now, once they get them in there, we've done this step. We put a comment here. See that? That's what we wanted to accomplish. And we got it running. And I want you to notice, we didn't finish the whole problem. We didn't implement the whole program. We just implemented a piece of it. So this is called iterative development. Just do a small step at a time and test your changes. If you sit there and try to write everything out, you're going to get lost. You won't know where the problems are. So if you implement your solutions, implement your source code, write your source code incrementally, one little bit at a time, it's much faster. In my opinion. Actually, that could be an opinionated thing. So let's compute the addition and print the results. And there's two ways of doing that. We can straight out just create this expression and send it to the standard output stream. We can do it like that. Or we could compute the sum and store it in a variable called, s or sum, and then use that variable in this expression to print that out. Yeah.
It seems like, why is it necessary before you put C in or C out that you put STD down?
Very good. You're like reading my mind, really. That's fantastic. Ask a question. I'm thinking, should I tell them how to get rid of the STD now, or?
'Cause it just seems
So-
like a lot of
I will-
it seems like a lot of
It's extra sensory here, really. I want to show you how to lighten up the load here a little bit. So I use using namespace STD. So I'm saying import all the names from the STD namespace. So we don't have to prefix those names with STD anymore. So we can actually take those out.
What's the benefit of using those?
Huh?
What's the benefit of using those in the memory?
What's the
Program
benefit?
itself? Yeah.
Only readability.
But
let's
what
see.
about when you're having a couple million lines of code and you have STD in front of everything? Doesn't that
Well,
slow down the actual program?
A lot of programmers they're not gonna use this up here because they don't want naming collisions. What happens if you're working in a program with a million lines of code and someone has a variable called cout? It's like, well, and then the compiler is gonna do something bad there, right? So if you're concerned about naming collisions, then you don't want to sort of globally import all the names from a namespace like this. So you got to use your judgment there. Some programmers, just by convention, will never do this. But for this little program, this is okay. Right?
Go back and like remove all the STD.
Because you don't know all the names that are in the STD namespace. I don't know all the names that are in that namespace. So when I invent a name that I want to use in my program, I'm just hoping that I didn't accidentally use a name that's already existing.
But aren't things like cout, cin, aren't those used as reserved words that people aren't supposed to be
No,
using?
these are not reserved words. These are not reserved words. Plus, a reserved word would be double. That's a reserved word.
So that's regardless of any namespace that you are using.
Exactly. Double is always there. It's not in a namespace.
Gotcha.
Yeah.
Sorry, in lab one, I noticed like in the code you put up online, it was kind of weird. It had like some weird code like c.arch or something like that, and I was just kind of like wondering what that meant. It had
It's online.
yeah. It was after integer main you put integer argc comma.
Oh, that. Yeah. You can.
And like I have no idea what that.
Let me
was.
talk about it later. All right, I want to overload people with that. That's a detail. You can look that up. It's in the book. Okay. I don't want to spend time on it right now. It's a good question. It's a very good question. And if later I can talk about that. But you can also look it up. So we declare X, Y, and Z. We read them in. And we have this expression, x plus y plus z, and that's evaluated first. After that's evaluated, we get some result. That result becomes the right-hand side of this output operator. And the left-hand side, of course, is cout. So we print the result of adding those three values. Once that's done, this whole expression here has just been evaluated. Like x plus y is done first, then that result is added to z, because that's left to right evaluation, because they tie on their precedence level. So first thing is x plus y, and then the result is added to z, and then the result becomes the right-hand side of this operator here. And then what I have highlighted right here is the result of that output operation. What is the result of that output operation? It's a reference to the output. It's a reference to the left-hand side, what was appearing in the left-hand side. So this thing that I have highlighted here, you can think of it as being replaced by cout. This expression evaluates to cout. This input operator, when it evaluates, its result is the object that appears in its left-hand side. So I used, mout. This highlighted expression would evaluate to mout. I don't know, it's a little hard to understand, but then this, you can think of this as collapsing down after the job is done. That whole thing collapses down and becomes C out. Now we have a left-hand side for the next output operator that will run. So now the left-hand side of this output operator is not that big long expression you see up there because that's already been computed. It's just C out. C out is on the left-hand side. Endl is on the right-hand side. We're going to output a new line character. Then I'm explaining how to sort of look at and understand that the syntax, how to think about it, how to mentally parse the statement. It's a statement. Statements end with these semicolons, and a statement is comprised of these expressions, and the expressions have some order in which they're evaluated. So you sort of have to start learning about how to look at these things and understand sort of like the sequence of activities of what happens. Yeah.
So that line is basically saying, you print the result of X plus Y plus Z.
Yeah. That's what it says. Let's test it. X is, well, 2 and 3 and 4. What's that going to be? Let's see. 2 plus 3 is 5 plus 4, 9. So I predict it'll print 9. 9, okay. Huh? So now I'm just showing you, don't just run it, think about it, do a little mental prediction. It's like you're a scientist. You made an experiment, you have formulate your hypothesis before you run the code. Have a hypothesis and see that you get what you're expecting. And if you don't, then you've got to go back and study where you're at. All right. Now we got to do other things. The sine of X. The sine of X. So we're going to compute the sine of X. And now here's the thing about the sine of X. It's another symbol. Sine is not a reserved word. It's not a predefined name. It's part of what's called a standard library. And so we need to, just like cout, we need to add an include statement to tell the compiler to look in the CMath library to find a definition of the sine function. But let's see what happens when we don't include that header. Use of undeclared identifier sine. We need to include CMath. There's other headers you can use, by the way. It's the C++ header. Question?
You have to include it in the header before you do the whole program, or for instance, if you're writing like a longer program, so you already have, say, 100 lines of code, and then you realize that you have to use the CMath, you can put it in before you start using it, right? Not at the very beginning.
This has to be, you can delay it maybe to here, but you cannot delay it to, this will not work. Because what it does is it does a copy and paste operation. It's just as if you open the file, highlighted everything, did a copy, and then went to your source code and pasted it right in there. So for pasting it inside the main function, it's not being, all of that source code is not being declared in the right place. And, rather than me just telling you that, let's not go on faith around here. Okay, so we're going to do it. Let's see it, all right? Let's see if that actually, what I said is true. Okay, what happened? I have never done this, by the way. So first time in my career. And I have faith that this is going to fail. Yeah, that's a terrible failure. All right, good. Thank God it failed. All right. So now we're computing. Now this compiles. We didn't run it yet, so we don't know how it works, but we know that this compiles. Let's Now, so we don't get lost, we ought to print some information here. Maybe I'll do this. Just have a little, I'll print out x plus y plus z equals, and then we'll print the result. And I'll do the same thing for sine. So I'll say sine of x equals. Let's see. It compiles, so that's good. Let's run it. All right, now we're going to do sine of x. So what's a number that, remember, we don't just type in numbers. I got to tell you it's a mistake. You got to make a hypothesis. What's that?
90 degrees.
90 degrees. Well, it's going to be in radians, okay? So what's radians for 90 degrees? It's pi over 2. What's pi over 2?
3.14.
What's that? All right, let's go 180 degrees. All right, let's do pi. 3.15149. Like that. I don't know any more than that. Huh?
Pi is 3.14.
3.15.
No, 3.14.
Start from the
3.
beginning.
3.14. 159.
Thank you. You did it all in unison. I got the message.
It's all math people answering right
All right. Oh, and what is the sign of this number?
now. Radiant.
Everybody knows that, right?
What is it?
Everybody knows the sign of pi?
Sign of pi?
Marie calendars?
It's 0. Guys, 0.
Pi is 0, yeah.
Yeah.
All right. Y is 2. That doesn't matter, okay? Oh my gosh. This is a great illustration. Oh, now wait a minute. Is this exactly pi?
No.
No.
And this is not exactly 0, is it? Because look, the E is scientific notation. It's 2 times 10 to the minus 6. That is pretty close to 0. So we got it, right? The hypothesis is correct. I'm not going to do the others, but those, there's these other expressions, so you can do the rest of those. Or maybe this logarithm. This is a little tricky here. Log base 2 of x. Let's try to do that. Log base 2 of x. All right, let's formulate a hypothesis here. Let's see, log base 2 of 1. What's that?
So you just put log, you don't put log 2?
I think it's log 2. That's why one of the reasons I'm doing this, because I can't even remember. I
Yeah,
think it's log 2.
It says log 2 on C++ reference, but when I type it into the system, it tells me that it's not identifiable. And then log x, which is
that the
5,
na-
it doesn't come out to the right one.
So this is a natural logarithm? Natural
I think
logarithm?
so, but it doesn't seem like it's giving me the right answer though.
Oh,
So that's what I'm trying to figure out.
So if this is the natural logarithm, don't we do this? Isn't that how you do it?
Yeah.
But some systems do have log 2. I think this will do it right here. So what's the log of base 2 of 1? Let's see, what number do you raise 1 to? Wait, what number do you raise 2 to get 1?
0.
0, okay. Got it, okay, good. So what's another one? How about 2?
Yeah, I know you're right.
What is this one? Log base 2 of 2.
1.
Good, thank you. I think it's good.
Divided by 1.
So and then there's other logs, right? So I don't know, I'm not going to go for that. Let's just see if that works. So let's try that. So I say 2 should come out 1, right? Oops, I made a mistake. Yeah, 1 right there. And then, and 1 should come out 0. It is right there, it's good.
So then since we're only working with log X, does it matter what we put in for Y or Z? Because I know you put 3 in.
Well, it's all part, this matter, so up here, see, so, you know, this, everything is all done in one program. So yeah, for our testing, we ignored Y and Z. But, you know, we're doing this in the context of a larger problem, which is to use Y and Z in other parts of the program. What about this? Does this work? Will that even compile? It compiles. And 2, so this should give us 1, right?
You didn't change your log to X, it says log 2.
Oh, yeah. Well, it should work anyway, right? Because we typed in 2 for X. Thank you very much for catching that. Very nice catch. So I know that on some compilers this will not be defined. There are some differences between compilers. If it's not defined on your system, then you'll need this, unless log on your system is base 2 log, and I don't know.
For turning it in code, if I was to
Yeah.
do it in Visual Studios, which doesn't have log 2, if I put it in there with log X divided by log 2, would you still accept that as a...
Yeah, this is fine. This is good.
Okay, as long as the answers are correct, right?
Yeah. And by the way, Jaren, who's grading the lab assignments, is using Visual Studio. He will run your code that you send by email to him in Visual Studio.
Oh, okay.
So if you have questions about Visual Studio, you can also talk to him about that as well. If you're using Mac and you have questions, you can talk to me. I can also answer questions about Visual Studio as well. Okay. On Mac, if you're using Mac, you need to install Xcode. Does everybody know that? Xcode.
Yeah.
It's free. Go to the App Store. It's a free download. Yeah.
In Xcode, the end L doesn't work.
What doesn't LD? The N?
Yeah, the
Uh,
end L.
ONL, natural logilogram?
No. End
EL.
L.
Oh, N. Oh, no, that works.
I kept
This is
trying-
Xcode. We're
Yeah,
seeing it right here.
It wouldn't work.
Did you put STD in front of it?
I did it just like how it's written there, and for
Show it to me.
every time.
Show it to me. But it works. I mean, you can see it works. Maybe you put a 1 there. You know, let's look. Does that look like Endel right there? Does it? Look at it.
Oh, yeah.
Does that look like Endel? It does, doesn't it?
Double check here.
And this. No, that looks like an O, doesn't it? Does that look like that's an uppercase O? Does that look like a 0? That would be pretty hard to find that bug, wouldn't it? I had this bug once. I want to tell you. I was working on my PhD. I had a string of digits which was several hundred digits long, characters. I had an O instead of 0, and it took me 6 months to figure it out. That's the worst bug I ever had to deal with, I got to tell you that. And now I think, oh, I should have figured it out. I mean, I could have figured it out in 5 minutes if it just occurred to me.
That must have been horrible.
It was crazy.
Imagine after you figured
Broke
it
my
out, you're like,
computer.
really?
Yeah. Well, that's the other thing about this discipline I want to sort of, highlight is that sometimes it's just a matter of persistence. You just got to keep going at it. You might see someone sitting next to you that are flying through all the exercises, but you had misplaced a comma somewhere, And it just took, somehow, it just was so hard to figure it out. Or there was a bug in the system, and you were using a system, you were relying on software that was malfunctioning. And your code, the way you expressed your code, which is correct, was triggering the bug, but this other person had a different version of the program. It had the same result, the same logic in it, but expressed in a slightly different way that's not triggering the bug. When you're dealing with a bug in the system, that's really frustrating. And that happens. Every software program out there, everything has a bug. All of it. You know, maybe if it has 100 lines, maybe it doesn't have a bug. So you've got to be pretty flexible, and you've got to be very persistent and on. Anyway, I don't want to get into that too much. So it's 1 o'clock, and we only did one exercise. Look at this, exercise 2. Oh my God.
It's a T-Rex.
That is a bug. That's a bug.
It's the Wi-Fi. It's down right now.
Is it down?
No, I think it's good.
We're gonna do it.
Cause your face.
You using
Oh dang.
what?
Interim.
Down?
Do the interim.
That's what
I got there.
Yeah, do interim. Don't use the other one. Because you have to keep reconnecting if you use the regular one. Use. And then your face is breaking it.
So, like, if we were to turn in lab 2, we would just email you and the TA the code, right? And then you guys would copy, paste, run, and compile it, right?
Yeah.
Gotcha.
How would you email it? First, you don't write it right there. I think Professor prefers if you handwrite all your code and just give it to him directly.
Oh my god.
Prefers really, like all your lines of code, you gotta write it
I
out.
think I probably died.
Yeah.
There it is. I'm running a local
Paper.
web server. See, that's nice and convenient. I don't even have to be connected to the
Oh,
internet.
nice.
So I have all of that site locally, and I could just run a local web server and look at it that way. So this is what it looks like. And look, this is what your first exam will look like. So this is direct practice and preparation for the first exam. It looks just like that. You'll fill your name in there. The problems, you'll have a snippet of code like this, and then they'll have a question like, when that code runs, what does it print? So you have to read the code, you have to analyze the code, you have to write down what it prints. You don't have to explain it in words. You just say, well, it prints 5, and you write 5. That's all. It just prints 5. But there'll be other things. This is reading and analyzing code. What does it print? And here's a different kind of question. How many times does the body of the for loop run in this code? So here, this is called a loop. This is a for loop right here. And this piece that's indented right there, that's repeated. And the repetition of that inner chunk of code is controlled by this expression up here. Well, these several expressions. And this is called the loop condition, that I is less than k. Whenever the loop condition, I less than k, is true, that the body of the loop will run. So looking at that code, okay, how many times does the loop run? 0? 1? 1,000,000? So you have to figure it out. You have to read it and know how to answer that. Yeah.
What does the plus I mean?
That means to increment I.
Yeah.
So if I was 3, when you run plus I becomes 4. It means increment I.
It depends what K is.
Well,
okay,
K is
then-
100, so
yeah.
99 is less than 100, so it'd run 99 times. But the increment is before it, so it would increment it first, and then it would rerun the code.
I don't know if you're starting at 0.
No.
Let's all
So
solve
your
this.
I is equal to 0.
Everybody focus on this. You got to know how to do this. Look at this problem. Figure this out right now. Stare at this. How many times does that loop run?
99.
Because it's going to run the first time, and then it's going to increment it from 0 to
It
1.
only runs as so long as I is
Less than K, so
So it's only going to run up until the point where it reaches 99.
Yeah, so
When it reaches 99, will the loop run?
Yes,
When it reaches 100, will the loop run?
No.
yes.
something.
No.
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 It will
So
not,
100
because the
times.
loop condition is false.
So it's 100 times.
If I is 100,
Because it becomes equal to, oh.
if I is 100, 100 is not less than 100. So the loop condition is false. That means we're finished with the loop. We're not going to run the body of the loop anymore. So when I is 100, the body of the loop does not run. But when I is 99, the body of the loop runs. Now when I is 0, I starts at 0, right? Does the loop run when I is 0? Yeah, that's the first time it runs. So it runs when it's 0, it runs when it's 1, ... it runs when it's 99. How many times do you run that? 100.
2.
But your first impulse was 99.
Oh yeah. We forgot
Now
about
that-
the 0.
Huh? It illustrates a famous problem called the off by 1 problem.
Ah.
So it's just prevalent. Almost every problem you work on, you always have to slow up and reason over exactly how many times something happens. It's very typical you're off by 1.
So,
It's very common.
Yeah.
just because I know we've had questions like for figure 1, it was like, oh, when you input this, what's the output? Does that mean that we're going to be able to work with like computers, or we're going to have to already know?
No, you're just write on paper. So I would give you, in this room, you'll sit down, I'll pass out sheets of paper, all you have is a pen or a pencil, no calculator, no books, no notes. You'll read that, and you'll think about it, reason about it, and write down the answer. You're going to write 100. You'll write 100 on your paper.
Please don't make us write out every single line.
Huh? No, all I want is 100, okay? I want to see
Okay.
100.
We did that for 27 variations.
But now look here. Look at number 7. Here's another type of problem. Write a C++ program. So write a program. Write a program that computes the sum of integers 0 through n, where n is an integer entered by the user. So you have to be able to write that program. Now, I don't want the include statement. I don't need that. I don't need the main, right? I just want the code. How do you input the number, and how to set up the variables so that you can compute the sum of values 0 through n. This is a standard problem, by the way. It's, it's like what's 2 plus 2. I mean, it's harder than that, but this is a basic problem that for you to progress and work on other problems in the course, that you need to know how to do this.
Do you want us to put the statement like C out, please enter in the number for n, or do you want to just put like C in and the number and just go through the primary code, or you want like just the whole bits and pieces?
No, I don't want CN because I'll tell you, and you can ask me that when you sit down and take the quiz. If you have that kind of a question, please ask that. Or the exam, I used to call them quizzes, but they're really exams. It says where n is given, it's already an integer entered by the user. I don't want code that does that. I just want code that computes the sum. And maybe I should rewrite that. So I write that, make it a little bit clearer.
Clear.
Yeah.
Mathematical code. Not
And
the
look-
actual school.
Look here, this is the exam 1, okay? And here I have the same type of problems. You just have to practice these. It's like taking calculus or algebra. You just practice one problem after another till you get good at it. So this is practicing. So you've got to practice it. So I try to give you as many problems as I can.
Can you press that button that says show answer?
Yeah, there it is right there. That's what I'm looking for. All right? That's what I'm looking for. This is write code to do something, and that's roughly what you're going to need to do, something like that. Write C++ code that prints 100 random integers. Right there. Where an integer falls between 0 and 99 inclusive. So we're going to talk about that. So you use the modulo operator here. This percent symbol, that's mod. So, 101 mod 100 gives 1. So it's a remainder operator. It produces the remainder. It's very common. It's widely used in computing problems. I think that's enough for today. Any other questions?
As far as the book goes, like what chapter would be in chapter 2 right now?
You can tell. It's obvious.
Okay.
Like chapter 2 or 3, something like that. Make sure you keep up with the reading. If the lectures aren't good enough for you, you gotta refer to the book, keep up with the reading.